Okay, be good to understand Vertiv. I know you've sort of gone out there and said you think that services or who operates best and not just construction speed are what might ultimately define the future of the data center industry. Just give us a bit of, sort of background to why you're sort of saying that.
Yeah, look, so I'd say on a couple of different points, that point becomes relevant. I think, firstly, if we think about the construction phase of the life cycle of a data center, it's typically 12, 18, up to 24 months. However, that data center then must operate for 15 to 20 years. Okay. So actually, when you think about that in a general, context, construction is a sprint and operations really is the marathon. So, once we've got past the initial speed to market advantage from our co-locator, hyperscaler, or neo cloud, whoever's building the actual data center, we then flip into downtime or early equipment degradation is really the focus point then. So how can we make sure that that initial upfront infrastructure investment is protected through the life cycle of a service contract? And at Vertiv, we look at everything from end to end. So once the product leaves the factory, from a service perspective, we're involved in that delivery, installation, positioning, commissioning, handover, right the way through to our life cycle operations. So into that contract and non-contractual opportunities, right into then optimization and right through to retrofitting as well, to try and keep those assets working in optimal condition as long as possible through that life cycle of the data center. If we then think about how the industry's shifting, it's shifting from just product selling to system selling. And if we look at for example, our Vertiv One Core architecture, we're moving from that room full of products to a unitary coherent system. We can't then service a 600 kilowatt AI rack using that siloed electrical and mechanical teams. We need a service partner that looks at a facility as a single unit of compute. So we're investing heavily in our training development of our people, our engineers, our project managers, to give our customers that turnkey, one single vendor to help them in their ambitions. The third thing I'd say is that uptime is a competitive product. So for co-location providers, the service that they sell to their clients is 99.99% uptime. If that isn't achieved through speccing a building, that's achieved by our engineers and our 24/7 monitoring and our Vertiv Next Predict platforms to make sure the infrastructure adapts to the real-time workload spikes, and also allows us to see when we may need to intervene in a data center early outside of traditional maintenance schedules to respond with the right engineer at the right time with the right parts to make the repair before any failure has occurred in the data center. So that's how I would kind of summarize the why service is such an important part of a data center life cycle.
Yeah, and is it fair to say that with the rise of AI workloads and the higher and higher density environments we're seeing, is that reshaping the importance of I mean, as you've emphasized there, it's always been important, but is it becoming even more important, if you like, service capability for operators, bearing in mind what's going on as they with AI?
Yeah, absolutely. And I think, look, even if we look at the cost of the chipset, right? If we look at the cost of a GPU versus a CPU, there is a significant difference where infrastructure and maintenance becomes a very small part of the overall investment. So absolutely, any second of downtime will have impacts on potentially the chipset, but also potentially the ability for that to generate tokens, which ultimately will generate the revenue and profitability for that upfront investment as well. So, as the criticality in the infrastructure increases, the criticality of a professional global service business is absolutely needed in that space.
Okay, and I know, Vertiv, you promote the fact that investing in services shouldn't be seen as a cost, just but a way to protect the things that matter, the critical infrastructure. But perhaps you can expand a little bit on what operators stand to lose if they don't get the service piece right. Well, yeah, what are the consequences?
Look, for sure, right? So if we think about 100, kilowatt plus rack environment, and When you hear from NVIDIA, they're talking about numbers well beyond 100, plus. A pump failure in a CDU, for example, can lead to hardware damage in less than 60 seconds. Okay, that hardware damage and effectively takes potentially units of compute offline for a period of time, which will impact, that perspective. So, traditional reactive service really is obsolete now. Whereas back in the day, we'd come and maintain your UPS 2 or 4 times a year at a defined frequency. But actually, in between those service events, other things could have occurred in the data center, which in essence could have taken that down. If we look at something like our Vertiv Next Predict solution, we're able to catch that pump's vibration or flow deviation before the failure comes. So we're able to use, quite advanced algorithms to, understand how an asset or a system is performing and effectively respond to that in advance before failure occurs. So that would be one of the areas I would say there. The second one is if you think about most AI sites today, they are hybrid. Okay, we'll have water and we'll have air. So really, the skill set of that engineers is critical. So if we look at our multilingual technical team, we need to understand high pressure refrigerants and secondary fluid networks. So gone are the days where you're just a UPS or a chiller expert. We now look at our engineers as powertrain and thermal chain, okay? And we are organized in that way. And we have obviously our training and our development of our engineers, spread in those defined, areas. So we're really investing. So a thermal chain engineer can look at everything from a CDU, a secondary fluid network, all the way through a chiller or a CRA. And that is really important as we look at these complexity of the AI data centers.
Okay, and regulation tightening globally. Are there any particular new compliance or safety expectations which are putting pressure on operators? And again, coming back to service, how can the sort of strong service framework sort of help address what's already happening and maybe, as much what's potentially coming down the line?
Yeah, I think there's always been challenges there, but I think if we look at the most recent ones around AI data centers, there will be millions lost every hour of lost training time. So effectively, if they're not producing tokens, that penalty or that cost is significant, whether it's from a neo cloud being penalized from a hyperscaler or whatever those liquidated damages look like. But that is significant. I mean, there's various figures that exist in the industry, but you can look at that sometimes it can be beyond $10,000 per minute average downtime cost. You've also then got the reputational damage of an AI, cluster going down, and it can result in anchor tenants, fleeing to a more, reputable provider. So there's an element around, we need to be ensuring that we can support our customers to maintain uptime, or when something is going to go wrong, we can try and predict that through our Vertiv Next Predict solution, or we can have things in place that we can respond quickly and we can get, that cluster back online. Second thing I'd say is, the asset life destruction. So we think about something like thermal throttling, okay? So poorly maintained cooling can lead exactly to that thermal throttling, which slows down the compute performance and reduces the physical lifespan of the silicon. So services allows us to protect that, sometimes 100, 200 plus $1 million of investment inside the racks. The third thing we're seeing is, as NVIDIA is reporting out, there is changes that are foreseen in the future. So if you think about 800 volt DC environments, the shift to 800 volt DC architectures is essential for AI scaling, but it introduces higher physical risk. So we then get into how are we protecting our employees? How are we leveraging technologies? What are our safety standards around that? Because getting the service piece wrong isn't just a business risk. It can be a life safety risk for everybody on site. So, that is really an advancement that we are already investing heavily into understand from a product perspective, but also understand from a servicing and a personnel and a safety perspective.
Okay, and another issue to potentially add to the mix is the supply chain. I mean, clearly there's always potential bottlenecks, but I think they're becoming more of a persistent challenge. It's fair to say, bearing in mind what's going on in the world. Is there a role that services play when it comes to building sort of resilience and helping to reduce operational risk in this sort of in uncertain environment?
Yeah, look, I think so. I mean, we know now that depending on the data center that's being built, there's redundancy naturally built in it. If we're able to, demonstrate through our Vertiv Next Predict that we can effectively guarantee uptime, or we can change our contracts from a traditional service contract if we come and maintain X number of times per year and start to guarantee that uptime, it effectively can remove a whole layer of infrastructure in the data center environment as well. Um, but in terms of supply chain, I think what we're doing at Vertiv is really doubling down and making sure we have that supply chain resilience. So yes, service on the back end can help to reduce some reliance on supply chain, but I think it's about working at it from both angles and making sure we have a very strong supply chain strategy, a really strong focus on supply chain resilience as well. Looking at our vendor strategy to make sure that we can deliver to our customers when we need to deliver also. So I think it is a joint effort there, Phil.
Okay, and from a practical standpoint, can you give us a sort of what a truly comprehensive data center service offering might look like today? I mean, I'm sure you could give us a lot of it, but give us the sort of key components of such a strategy.
Yeah, I'd probably break this into four specific buckets. Number one for me is this AI-powered Next Predict managed service. I spoke a little bit around Vertiv Next Predict. So really is a 24/7 cloud-based analytics that moves from what happened to what will happen. And that's a clear difference in terms of, how we used to service versus how we are servicing now, and really using high resolution asset telemetry. So when we're designing a product now, we are very much saying what data do we need to capture from this asset that will feed into the system level algorithms to understand the system health, and that's really important. But that is a big shift. Second, I would say, is a unified grid to chip support. So really a single service contract that covers everything from high voltage switchgear right through to energy storage or BESS, for example, right the way through to direct to chip cooling blocks. So, for me, it's the full end to end. It's no longer, as I spoke earlier, around a single, product. It's a system. And being able to service the system is a key differentiator that we're able to leverage at Vertiv as well. Third, I would say is more leverage around digital twin operations. So looking at many people misunderstand a digital twin and see it as this nice to have, cool model of the data center. In at Vertiv, we see it very differently, is that a digital twin should be leveraged upfront through design of the data center, right the way through the commissioning of a data center, and then handed over to the operational running of a data center. So making sure that we can simulate complex maintenance tasks, we have that virtual environment before we touch any live high density AI clusters. The other benefit of that is if we think about Europe, for example, there's a lot of legislations that are coming in around, incoming water temperature and things like that. We have to conduct very advanced studies to get the answers of what would happen if we changed that. Whereas with a digital twin, you can very easily simulate changes like this. And that really lends into our focus on optimization of the data center, not just maintaining it, it's continually optimizing it. So digital twin absolutely supports with that. The fourth thing I would say is that as we shift to these more, super size, gigawatt plus campuses, it really is looking at on-site resident engineers. So looking for, mission critical AI factories is really having, Vertiv certified experts on 24/7 to manage liquid cooling chemistry, high voltage, power transitions, but effectively respond and proactively, drive towards anything that can be changing in that data center environment. So the on-site residents are looking at the whole, powertrain and thermal chain is a super important component for Vertiv services.
Okay, and when you're talking to customers, potential customers, are there any particular sort of common service gaps that you come across when you're talking to the data center operators? And I know you sort of earlier mentioned sort of the consequences of when things go wrong, but are there I mean, from the sort of, I suppose, trivial things up to obviously, shutting down, and we know that, but just give us a flavour of the consequences of those gaps.
No, for sure. So I think one of the things that we see often, and it's this is everywhere in modern day corporations, is a silo. Okay, so we see that in our customer base that the IT teams manage the GPUs, but the facility teams manage the UPS, or they'll try and break it down as products. And the consequences for that is that a sudden AI spike trips a breaker because the cooling system didn't ramp up in anticipation. So we really need to educate ourselves, but also the customers and the industry, that it isn't about having individual silos. It's looking at this holistically and trying to move away from this old, oh, well, this is CapEx, this is OpEx. Actually, it needs to be looked at everything together, because, what you do up front will absolutely impact the downstream of the running of that data center as well. So trying to break down those silos, or at least understand the silos and where that can cause friction, is important for us to work with our customers to make sure that's understood. I'd say, secondly, the liquid cooling, a bit of ignorance around what liquid is, and we see a lot of people in the industry treating liquid cooling like standard plumbing, and the consequence of that is of using the wrong fluid chemistry, or failing to monitor for micro leaks, that can lead to corrosion. Inside multi-million-dollar racks, can have significant impact and cause downtime. And I spoke earlier about the significant impact of that downtime in a data center. So really truly understanding secondary fluid network, or primary loop down to secondary fluid network, why each part of that needs to be optimized and commissioned and then maintained in the right way to effectively allow that to flow through as well. And then, trying to move, the industry away from, let's do maintenance every 3 months, let's do maintenance every 6 months, regardless of use. In an AI heavy rack that runs at 95% load 24/7, fans can wear out a lot earlier. So, we can't just maintain at certain blocks. We need to effectively, use telemetry to pull data of the system, how the system's working, use our algorithms to predict and understand when a failure may occur. So really trying to move the operational team mindset from, let's just stick to 3 months, 6 monthly maintenances, and actually looking at it in a very different approach, but also trying to tie that into an outcome-based approach, which then helps, our customers, support their customers in terms of their SLAs and their agreements of uptime.
Okay, and if you were talking to an operator, are there some sort of top things, or even sort of table stakes, in terms of what they should demand from a service operator to make sure that they've got, uptime, efficiency, and as you mentioned earlier, safe operation as well? What are the sort of must-haves when it comes to a service partner?
Yeah, so I think our thought leader customers that we're seeing there really are demanding, don't tell me when it's broke, tell me when it's about to break, and better still, fix it before it breaks. And that's where our Vertiv Next Predict really comes in. It allows us to effectively do that. Liquid cooling specialists, making sure we have, they have the accreditations to work on that. So, do your techs know how to service a 600 kilowatt CDU that handles PG25 coolant? We often see that we try to be dragged into a bit of a commodity race where, the CDU is trying to, a lot of people are trying to drive the CDU as a commodity, which then you try and commoditize the service. You really need those experts and those specialists to be able to maintain that. As I said, the CDU and the secondary fluid network is, holding up some significant investment in the racks. The GPU cost versus the CPU cost is significantly different. Holistic data visibility. So we have a lot of customers that are saying, hey, we want to have a single pane of glass, a single dashboard showing the health of my, units simultaneously. And again, that's something that we have in our Vertiv Next Predict, portfolio, or our Vertiv Unify, that really allows us to give that single pane of glass to our customers as well. And then the final one I'd probably say is around spare parts strategy. So yes, we know things can go wrong, but do we have crash kits? Do we have spares on site? We spoke about supply chain resiliency. It's no different for that in terms of being able to repair or being able to proactively replace equipment. That, if we need to replace a fan and it's a 10-week lead time, that's not going to help if we see that it's going to fail in 4 or 5 weeks, as an example. So making sure we have a proper spares strategy with our customers, on-site crash kits and central spares, enabling us to effectively get those spares to the right place at the right time to enable our customers to do what they do best, which is ultimately generate tokens or keep our IT infrastructure alive.
And in terms of the feedback from the customers, is it a case of if you don't hear from them, you're content because there's no complaints and everything's running well, or do they actually tell you when the service capability that you're providing is they maybe flag up an incident, say thank goodness we had this or this in place? So just any sort of feedback I suppose you can give us as to the real world where service capability is making a difference.
Yeah, look for sure, and I think this is where we see we call I've used the word customers a few times. I prefer typically not to use that word, to be honest, because I see this is very much as a partnership. We are effectively maintaining and looking after hundreds plus millions of dollars of IT infrastructure. Okay, so it really is working together. So we've seen real life examples where we've actually been able to reduce energy. So we've been able to look at this optimization of equipment on site and really reduce that energy usage. And we've got examples where we retrofitted a global telco's cooling with energy efficient fans, intelligent controls, and we were able to reduce that energy usage so significantly by above 50%. It allowed them to add more servers without increasing their grid connection, because we always know there's this dependency on the grid as well. So we have real life examples of energy savings. And in Europe, we partner with one of the largest telcos and look at that energy reduction model. So we're saving them significant amount of money by just purely optimizing their current footprint, their current equipment, looking at new equipment when energy efficiency, when we got more energy efficiency equipment there, but also just generally giving them a single pane of glass on how their data centers are operating. In terms of batteries, I think batteries is probably another good example. We can, with our Vertiv Next Predict, we have an example specifically where a hyperscaler identified a high internal resistance battery. And we were then able to replace that during a scheduled window, which one, avoided a failure, but two, avoided further disruption of them having to get another engineer on site and potentially look at redundancy and potentially risk any other downtime as well. So when we can kind of understand what's happening in advance with the equipment, when we do have to visit site, we can do more than one thing. We can try and do 3-4 things to make sure that uptime is protected for that particular customer as well.
Okay, maybe just in finishing up, looking ahead, are there ways in which you expect the current service models to evolve further over the next few years? Obviously digital transformations at pace, AI, and sustainability, which we've referenced as well. So just your thoughts, I suppose, as to what we might see with these service models over the next few years.
Yeah, the future is definitely exciting. I mean, we're starting to talk a little bit around, robotics and some of these exciting things that can drive maybe further out than 5 years, but definitely that's something that we can, we're starting to look at now as well here at Vertiv. But I'd probably say that this autonomous infrastructure is something that we will see evolve over the next 5 years. And when you see the announcements from NVIDIA, you'll see some of those autonomous infrastructure pieces that they're talking about. But really having systems that will use AI to perform self-healing, automatically shifting coolant flow or rerouting power when an anomaly is detected, for example, in a Vertiv One core, and leveraging that system to move things around to mean that there's no loss or there's no drop in that token availability. I'd say, a rise in energy autonomy as well. So looking at service partners transitioning into more microgrid managers. So also looking at things like on-site hydrogen fuel cells, long duration energy storage as part of the data center's core uptime strategy. So, really looking at that autonomy of energy and looking at the holistic, system, not just the product piece. And then I would say, really interesting part is this, augmented reality field service technician, probably the step before robot. I'm not saying service engineers will ever be replaced, but the more mundane tasks can be done smarter, which then allows our engineers to be doing probably what they enjoy doing, which is the more complex fixes. And that then really helps us to leverage around this industry where we are seeing, skills, sometimes difficult to come by, which is why we're really doubling down our training and our early careers programs. But if we can get the more basic tasks done autonomously, and our engineers focus on what they enjoy doing, what they're skilled to do, what keeps their brain working, is a win-win for everybody. But things like AR glasses to overlay digital twin on physical systems, that type of thing it sounds very high tech and very, space age futuristic, but those things are becoming a reality now as well. And we are investing in that technology. So I'd say more of an augmented reality or more of a more robotic, supporting way of working in the future. That's how I would summarize that evolution in 5 years. But the speed of this industry is moving. That could be 2 years, could be 3 years, could be 1 year. So I think that's the exciting part of this industry, that typical timescales for advancement are somewhat compressed, which is fun.
That's great. I mean, it's been brilliant to chat, and thank you so much for sharing so many great insights into the sort of the service situation, if you like, and sharing Vertiv examples. It's just been fantastic. So, Phil, really appreciate the time you've given me. Thanks so
No,
much.
thank you for your time. Really good. Thanks, Philip.